thì mình bóng mình thì có một mặt thì
You have a lot of people in the especially
trong cái học trong con sẽ được chỉ để bây giờ phải chắc phải cho dọn cười phải cái sự tích cực là chắc về express cho nó
cannot play the choice.
Người ta ít hơn về những học viện bị
chắc là phê đại chắc là phê đại lại quay một cái gì còn cái sự lệch system nó được làm dùng sẽ check like contract nó mình check đây rồi that and complement check cái gì
hàng thì của
hay là hai cái các cái điều kiện sự complement của cái xung quanh là xung quanh là tôi đi học ngoài đi học là học cho không tiền có được bạn nhưng bên tôi tao nó không học cho được lái mà học cho từ bên cho các bạn
So it is only extra.
Yes.
Không còn nước tới chân thôi quen tao đã tay thật rồi hay chụp được hay hai học vậy ra học chân ăn nó đấy
được bên ông bay xuống nè
ông còn đỡ mà họ chưa mà scan đâu thằng nữa đã score tiền là cái thằng ai tay buồn đã cho lên tiền có con ai nào mà hiện ra mình sẽ lên tận mua ai cả đi tay vô nó phải ba tay phải được đi mua sáng phải cái này rồi pin color là buồn rồi
trẻ ai không có nhìn trên frame thì thêm hơi cuốn
thật buồn rồi đấy
các bạn không thể ăn thì việc đi
dạ bên tiền này
mẹ sợ chơi với bạn ta sẽ đau quất
nghĩ cái toàn tăng cường đó cái bên du mà ra tay chụp em ta tiếp đây mà tiếp đây tiếp phải ai đó là ai bắt qua để họ chua luôn đó là tiếp nó trong quý buôn rồi mà lúc xưa nó chụp ăn từ bảy khó theo này đi khó đó ôi chị ăn mà chua này sẽ làm để tôi ăn cái này để làm để xong mà không phải bây giờ nó lại lại ăn không mấy kia ngày mình ra nhâm bài bên kia ngày ra nhâm bài hay mình cuốn cái xong rồi bị trong máu là bị hai xe nơi tôi ấy nhóm đã được thấy cái trong hai ít đi ít đi tin chết lên sao lại chết để đây là ông bị đá liền thằng chắc của em thật hơn hai nhau phải phải để mà bởi mùi khi ở đây đây là hai xe cái trend đó là làm bằng vì sao sẽ là cái khá hiện trend cho mấy cái quen quay hai lại cho cái bóng sẽ tàn tù liền rồi bây giờ phải chúc hai lúc này bây giờ cái trong chúc nơi nào Xong rồi đã bị lọc đó. Nó cũng bị xa nên vừa rong vừa tay vừa hai chứ. Tại nó bị lơ món này nó không bị người ăn thì những tuần cái cái hai cái môi của một mặt tờ. Cái này mà nhà bên này nó sẽ tên cái này là con ăn thì này nên nó mạnh trong á. Nó là cái tờ bao giờ nó có đến nơi. Nó được nhà mặt tiền ai lebih nó suka aja orang kena mau dan lu kena lain kalau kayak
Alright, we're going to continue on chapter 7, and anybody has forgotten their chapter 7? I have extra here. Please come here. I landed yesterday and it says 37 degrees Celsius. 37 there. Yeah, it's summer. Hello. Alright, good evening everybody. Welcome to our class today. We are going to do the following today. First off, we have not completed our discussion on risks and uncertainty. Okay, so what are we going to do today? We will start, you remember we ended up with an activity, correct? Yeah? But we have not finished. We will use that activity. What was the title? You remember the ticket agent? It was a ticket agent. You remember? Yeah, he was selling tickets, buying tickets and selling tickets, right? Okay. So we're going to use that to practice give me the three ones, the three decision techniques when they have, there are risk seeker, risk averse, and risk neutral, correct? Okay, what was the first one? Maxi, Max. Who is this kind of person, decision maker? This one is Maxi Max is a risk seeker. Very good. The next technique is called Maximin. What kind of decision maker is this? Neutral? The one who does not like risk? Not adverse. Averse. Without the D. Averse. Okay. Alright. Now, last one, not the least. What was that last one? Minimax what? Minimax regret. Minimax regret. What kind of decision making is this? Risk neutral, or does not have anything to do with risk. He doesn't care, okay, about risk. Okay, now. He does not consider risk. Now, in risk assessment, risk and uncertainty, we have not yet completed what? We have to talk about decision tree. We have to talk about sensitivity analysis. And we need to talk about simulations. Okay? So, before we talked about the maximum, we also talk about expected values. You remember expected values? Yes? What do you need in expected values to calculate expected values? Probability and outcome. Okay? So if you are to compare, you would choose the one that has the highest total expected values, correct? Total expected values. Alright, good. And hopefully that will bring us into the break, if not before or after. Then, the next one will be chapter 8. And chapter 8 is on budget systems. Yay! We are now in our third part of our syllabus, budget systems. Alright, so, by the way, a couple of reminders. Okay? We are going to meet today, and then our next meeting is 24th March, which is a Sunday, which probably we will talk about chapter 8 and chapter 9. Okay, chapter 9 is on budget as well. And then we are meeting one more time today, this week. So Monday, I will miss you so much. Otherwise, we have to work on a Khmer New Year. We don't want that.
One full time.
Yes. So we go to chapter 10, which is quantitative analysis and variance analysis. Okay, I hope we can cover, but I don't think so. All of that, but we'll try. We'll try our very best. Okay. Something else. I need to tell you. There is a midterm exam for you to practice. When is that? 30 March. Sorry. What is the Sunday? 31 March. Sunday is your midterm exam. Okay? It is a practice from chapter 1 to chapter 7. Okay? Chapter 1 to chapter 7. A combination of objective questions and long questions. So, chapter 1 to chapter 7. Okay? Chapter 1 to chapter 7. Alright? So, this is our program for the week and the week to come. Alright? Any violent reactions? Okay? Alright, everybody, please take note. Get everybody seated. Okay, ready? Since you're all talking to each other now, I suppose you don't need my slide. Let's begin with the ticket agent. Do you remember the ticket agents? What happened to the ticket agent? The ticket agent has a choice. You remember? Has a choice to what? To buy 200, 300, 400, and 500 tickets, correct? Okay, so those are the choices. What was the situation? The situation was, what can he sell? It's not in the slides. I gave it to you as an work on Saturday, on the last time we met. Yes? So if it's not there, the question, where is the question? The question is in your Google Classroom. Oh my God. Open it up on your computers or on your phone. And the results of these, I sent it to you via PDF. All the Google Classroom. So if you're not opening that, I cannot help you anymore. Okay? Everything is given to you. Open it. No internet? Who said to you there's no internet? There is internet. You cannot just do Facebook. You can do your Google Classroom There's two things that you cannot do with the internet now. YouTube and Facebook. But all else you can access. Try.
No password.
You sure?
Password, madam.
Password. Okay, you need password. I give you the password. Open your app. Okay. Our password is. Okay, that's the password. Open your mobile devices and look at the problem that I am talking about. Go to the Google Classroom. You will see my OneNote of last time. Still not? There's no internet for any other thing, but in your Google, Yes, you can open your email? Yes, you can. So everybody can. I can. Yes? The question? Below. No, not this one. Go back. Go back to. Yes. Let me check this one. No, wait. Hold on. Still loading.
Oh, yes, the become votes.
This one. Yes? Alright, go to your. Alright, let me see. Let me go to mine so you can see. Alright, if you're in the Google Classroom now, you want to see this problem, it's here. Okay? You see this? March 17 is a new assignment, I says there. Yes? Can you click that? Yeah? New assignment. Sorry. Okay. All right? And you will see this. You see this one? Yes, have you opened it? Alright. This was the ticket agent, remember? Okay, everybody open? Okay. Look for it. It says March 17.
On the PDF.
Yes, it is PDF. Can you open on your phone? Got stuck? Slowly, wait now. Wait. No, you have to be patient. It's coming from Shimmer. Yeah, because it's in a. Wait. Come take. Yeah. Oh, very good. Very good. You close it? Here? Okay, so you go click there. Alright, let's see here. You find it? March 17. Okay, attach. That's the result. That's the answer here. Yeah? Open that. Then we will see. You go to the don't know if you want that. Let's just take this one. New, yes. March 16, yes, it's Friday.
Example number 9.
No, hold on, sorry. Yes, clarification. No. Yes, all right. Okay. So this is the ticket agent. So you guys open it already? Still? My God, there's no. How about you guys? None? Okay, good. Now, what happened here? We said we learned how to do what? You look at my results. What did we see here? We learned how to calculate expected demand, correct? What are these? This guy, the ticket agent, buys the tickets. Do you see the tickets here? In advance, correct? So when he buys it in advance, he gets a discount, this much. Okay, but he sells it at the same price he bought it. You understand? So he buys it at, the cost of the ticket per piece is $30. Okay, but he buys it in bulk, he gets the discount. When he sells it, he still sells it at 30. So whatever is the difference between what he sold and net of discount is what his income is. You remember? Okay. Then, the first thing it was asked to us, the type of tickets depend on the kind of artist that is performing. And what are the different kinds of artists? Do you remember? Yeah. Popular means 45% usually is popular artists. Lesser known artists, 30%. So what are these? These are your probabilities, correct? Okay. So when the question was, what is the expected sales demand? What would you do? You will take the outcome. Okay, what are the outcomes? It says, where is the outcome here? This is the probability. It says, the outcome is, if it's a popular artist, 500 tickets can be sold. So that's the outcome here. Okay, the number of tickets. Lesser artist is 350. So when you use expected value, what do? Expected value, you take the outcome. Okay, what's the outcome? 500, 350, and 200. Okay, let me just make it a little bit bigger, you guys, so you can try to make sure you can see it. All right, so what is this? This is your outcome. This is your probability. What is EV again? Expected value. So what do? I take and multiply with the outcome. So this is the expected value, or which is the weighted average of the number of tickets he can usually sell. Alright, do you understand? Usually sell. That is what it means by expected values. Okay? Now, the second thing, it says, alright, now what if, alright, we actually find out and work on, okay, expected value using the payoff table. So what we did was we started to actually prepare a payoff table. And what is a payoff table? The payoff table has two factors. What are the factors? What are the two rows and columns? Okay, one could be what? Situation. And the other is? Say what? Choices. Choices. In this case, what was the situation? The situation is the sales demand. In other words, remember? Less popular artists, you remember? Yes? Popular artists, lesser known artists, and unknown artists. That is your situation. What is the choices? He can either buy 200 in advance, 300, 400, or 500. Now the question here is, what should he do? Okay, what would be the best? Now if I were to use expected values, okay, expected values in terms of outcome, I need to complete my payoff table. And what is in here in a payoff table? This is the situation. This is the choices. What's in here? What should I write here? Profit. A payoff table is the profit he will make. How do I calculate the profit? You remember how did we calculate? You have to look at the table. If he buys 200 and he sells all the 200, correct? What is his profit? Okay? So, then we did examples of what if he buys 300 and sells only 200. Do you remember? We did that, right? And so on and so forth. So we did continue that. So how did you get negative 570, for example? Okay? So negative 570, first you sell 200. But what did you say? 100 out of the 200 is returned to the box office. You remember? And how many percent get sold out of the 100? Only 10%. And then at what price? Only 60% of the price. So that's what he makes. But the 100 has some cost, correct? Okay. So the cost of that is 260. So he gets a loss if he buys 300 and only 200 is sold. Okay? So you can continue doing that for the rest of the problem, correct? Okay? So what happens now? Did I send you the... Okay, here's the thing. Alright, so if I do that calculation all together, okay, I will do the shortcut now because you know how to do that. Okay? Alright, here's the thing. Alright? Here is the final payoff table. Okay, what is this again? This is our payoff table. Let me just put a name so that you can actually know what it is. Okay, so this is our alright. So payoff table. Alright? Now, in here, remember, this is our problem of what? Ticket agent. So that when you see this, it's, you know. So you have the situation, and you have the choices. Alright. What I want you to do now, okay, if it was maximin, huh? Alright. What should be his choice? Now, what is maximin? You choose the one, which one first? The min. Okay. For every what? For every choice, correct? You understand? So which means you go this way, because you always do the choice when you do maxi, correct? Yes? Except for when you do the opportunity loss table. Alright? So now you're going how? You have to go, okay, let me write mine here. So you have to go, okay, wait, pen, I need a pen. Okay, so you have to go this way, correct? This way, this way, this way. Right? Okay, so 200 first. What is the min? There's no min. It's everything the same. Correct? So our min is what? I'm sorry. Okay. Okay, so here would be what? 1,200, correct? Lower. Hey! What happened? Okay. I don't know how to do that. How did I do that earlier? How do you? Sorry. Sorry, guys. Oh my God. Okay, is that big enough or no? I have to make it bigger. Okay, is it okay? Yes? Okay, everybody can see. Okay, next line, 300. What is the minimum? minus what? 570. Okay. Alright, so what are we looking here now? We are looking for maxi what? Okay, so we're looking at maxi mean. Okay, so if it's maxi mean, we look at the minimum first, correct? Okay. Now, minimum return. Next one. What's the minimum? What's the minimum? If they bought 500 tickets, okay, minus 2040. Okay. Next one, minus 2460. Okay. So you have all the list of all the things that could happen, correct? Okay. Now, if I am doing maxi-mean technique, okay, what is the choice? What would be the choice? Maxi-mean would be? Maxi-mean, everybody?
Maxi.
Maxi, which means? 1,200 is your maxi. Yes, you understand? So 1,200, which means how many tickets should he buy? Okay, in maxi mean number of tickets would be 200. Okay, so here tickets would be 200. He will buy in advance. Do you understand? Okay, now let us take the same thing, same payoff table, and do for me maxi max, please. Okay, maxi max. Okay, I will write it down here so you have space. Okay, maxi max. I need maxi max this time. What is maxi max? What number of tickets are we looking at? Okay, so how many? First, we need to look for the what? The max, correct? So, line by line, we need to look for the max. Okay, so 200, of course, there's no max, it's all there. Next one, what is the max? 2,250. Next one? 3,600. Okay, and then? 6,000. So the decision point, remember, we're talking about making decisions, correct? Okay, so the decision point is the ticket has to buy, the ticket agent has to buy how many tickets now? 5. Okay, so the best for him is tickets equal to 500, correct? Okay, now let's go to minimax regret. Can I use the same table? No. You have to convert this table into opportunity loss table. Okay, so, okay, 1 second. Let me just copy it for you. Okay. Okay, so here, I'll copy here, but I have to erase something. Okay, this will no longer be what? This is no longer going to be payoff table. What do we call it again? What do you call it again? Opportunity loss table. Correct? Now I have to erase this. Clear it. Tell me, what amount should be here? Where do I go? Do I go from left to right or from top to bottom? Okay, remember, if you're doing opportunity loss, you have to do it from where? From top. Okay, you have to do this way. So what is the best choice if the demand was 200? What is the best choice if the demand was 500? Tell me. What should I do? Let me see if you remember what can be done. Okay, so let me make it a little bit smaller so you can see what I'm doing. Hold on. All right, here's the thing. Okay, so if it was 200, what is the best situation? 1,200. So it means that he has to buy 200. So opportunity loss here is what? What is here? 0. If that is the decision he made, then he will not regret anything. How will I calculate the next one? So if he bought 300, oops, it's 1, 2, correct? Remember how to get the next regret is what? You should have made 1, 2, but you made what? Negative 570. So what should I do? Equal. So 1, what do I do? Let me. 1, 2 minus what? Okay, minus, I'm not sure if it can be. Minus what? Negative 570. Correct? Yes? Or, is that correct? Yes? Or you can do a formula. What is my formula? You can say 1, 2 minus what? Minus the third column, correct? Okay. Or if you're very good at it, you can do the constant, but I don't have the patience to do that now. So, again, 1, 2 was your best situation, correct? Alright, minus what? Minus what happened to you actually if you bought 500, correct? Okay. Now can you do the rest? Can you tell me, how about if it was 350? What is the best situation? Which one is the best situation? That becomes 0, correct? Can you complete the opportunity loss table? If you don't have the computer, you can do it manually. Okay. Make the table and calculate opportunity loss. If the internet is slow, you can also do. Done? Do you have the table now? Not yet. Okay. Very good. Very good, correct. Excellent. Okay. Very good, correct. Yes, excellent. Do manually if you don't have a computer, please. Where you know? Okay, what was your original best choice? Minus 2. Minus. Okay? Right. So again, your best choice minus what is the profit on the next. Or, okay, very good. Done. All right, excellent. Okay, so what is the best choice for level 350? The best choice is 300, correct? Okay, so if you did that, all right, so then it's this minus, okay, sorry, I just need it here. Okay, all right, then equal this. Okay, minus, sorry, yeah. That correct? Yes, yes or no? What happened? One. Okay, next one. Next one, what is the best choice? Of course, 6,000, isn't it? Yes? Okay. So, if you did the first one, what happened? Sorry. 6,000 minus 1, 2. Okay. Or you do 6,000, next one, minus 2, 250. Again, 6,000 minus 36. Okay. Now, so when you do your opportunity loss, you do by situation, correct? Okay. All right. Okay? Alright? Now, what do you do with this? You can now give me the solution for minimax regret. Minimax regret. Okay, tell me, which way should I do now? I am doing minimax, sorry, again. Minimax regret. So you start with the maximum regret, but you have to do it again now this way. You understand? Okay, so now if you do that, what is your maximum regret first? First line. If you did 200, would be your maximum regret? If the ticket agent buys 200 in advance, what would be his regret? How much? Maximum regret. 4,800. Okay, there's no minus anymore. You're already looking at the opportunity table. You're only looking at this regret. Yes? Alright. What is the maximum regret on the 300? 3,750. Next one. Maximum regret. 3,240. Next one. 3,660. Now you have to choose the what? You have to choose the, okay, so you have to choose the minimum. And what is the minimum of all the regrets? Yeah, sorry. Yeah, 3,200. Sorry, here, what was it? This one. I have to highlight it. Okay. Which means, what is his If it was a minimax regret.
450.
Okay, so his choice would be what? Tickets would be at 400 pieces. You understand? The decision in a minimax regret is to buy 400 tickets. Yes? Okay. All right, clear, everybody? Okay, so what I want you to do is you need to practice. In your revision kits, a lot of this is there. Okay? You have to, because this is a source of questions, because it has a lot of marks they can give you here. Okay? You understand? You need to practice this technique. Now, any questions on this technique? Are you okay? Yes? Alright, so use this to practice. And I will say this again on the Google Class. Okay? Alright. Now, but you don't open it. Yes, yes, no, not you. Okay? Alright, so please open the Google Classroom. Please. I send you a lot of information. Please. Do not open it only on May 25. You understand? It's only 1 week before the exam. Don't open it at that time. Okay? Alright. Clear. Huh? What do you mean? Yeah. Big problem, no? Oh, okay. Oh, we don't want that. Okay? So it's good. Now, let's go to decision tree. Yes? Okay, so can you open your slides to your handout to anybody else needs one? Already? Okay. Open the slide on decision tree. This is another technique. Okay, this is another technique. Any questions on minimax regret and expected value? All right, ready? All right. Decision tree is a diagrammatical way to represent a problem. Okay? Here, we are going to still use the probabilities. We will use expected outcomes. What do I mean by outcome again? Practice. And we need to use the probability. And then, which means we need to show what are the different options and what will be the outcome and the probability. But we have to draw it. How do we draw it? We always work from left to right. Okay? We put the problem from left to right. For example, if I was to decide on something, I will start with the left. And it has to be a box. The box is a decision point. Okay? In decision tree, a box is a decision point. So when there is a decision point, which means there are choices. The choices is in the branch. Well, why is it a branch? Because I call these a trees, right? Every tree has a branch. You know a tree? Tree. You know what is a tree? It's not there. That is why they showed us this room today. Because this room, you can see a tree. In the other room, you cannot see a tree. So this room is perfect for the topic today. Because we can see a tree. That is a very nice part of there. Yes? If you don't want to see my face, you can listen to me, you can look at the tree. Outside at the park. Yes? But I don't need you to see me. I need you to hear me sometimes. So if you don't like to see me, just hear me. Okay? So in a decision tree, there is a decision to be made and the branches represent choices. Can there be more than one choice? Or more than two choices? Yes. Okay, because there's only one, there's no choice. Okay. So can it be more than two choices? Yes, it can. So more branches, yes. Okay. Now, what else? What happened here? Sometimes a possible outcome, an outcome again means profit, because this is the profit against this profit. What decision will you make? Now, sometimes a result or outcome is not 100%. There is what we call probability. So there will be what? There will be an outcome point. Okay, an outcome point is when there is a probability that, you see what will happen? So there is a 70% probability that this will happen, a 30% probability. Okay? So, which means before I can know what is this, I need to say, for example, 70% they will make an income of 100,000. 30% they will make an income of 200,000. How much do you think I put here? It's the expected value, you remember? Okay? So if, for example, what is that outcome? Let me use this. What did I just say to you here? Let us say there is 70% that the outcome is 200,000 and there's 30% that the outcome is 100,000, which means the profit. What is the answer here? Okay, it will be what? 70 multiplied by that, correct? Which is what? So the answer here would be 200,000 multiplied by 70% or 0.70, correct? Okay, or better 0.7 because it's 7 there. Okay, equals what? 140. And then 100,000 multiplied by 30, which means it gives 1, right? 100%, right? And this one is what? 16. I think the electricity cutoff is in your brain. It's not on the electricity that comes. What is this? This is what? Is it 3,000 or 30,000? 30. So what is our outcome? The outcome here would be what? 170,000, correct? Yes? Okay. So what is this? This is called your EV. Yes? You understand? So the outcome will have the EV. Got it? So whatever is the EV here will be compared with the EV here. Then you make a choice. Make sense? Interesting, isn't it? Okay. Now, alright? So we will, of course, they will not ask you to draw a tree. I'm not sure if you can draw on the computer. Okay? But should you, they will actually give you a tree and then they will ask you to analyze it. So you need to know how to draw it so that you'll be able to know how to interpret it. Now remember, the EV can be, what did I call you? The outcome can be a profit, yes, can be a contribution, can it be a cost, a contribution or a revenue. In this case, you will have to choose the what? The highest, correct? But if the EV is on the coast, your choice should be the what? Lowest. You want to minimize cost, but you want to maximize sale, contribution, or profit. Do you understand? So when you make a choice, it's not always the highest, huh? It depends on what you're choosing. Okay? Now. Okay? So let's see an example. An increase in demand for car parking facilities has led owners of a car park reviewing its business operation. He has to decide whether to select one of the following 3 options in the next year. What are his 3 options? Okay, number 1, he does not make any change on his car park system. What happens? His profit, if he doesn't make any change, is 100,000. Okay? Now, if he raises prices by 50%, he says that, okay, all right, it occurs when there is a 75% chance that another entrepreneur will set up competition. Okay? The board's estimates of its annual profit in this situation would be as follows. Okay? If there is a competition, the profit will be 150,000 with a new competition at 30% probability. Without a new competition, the profit will be this. Okay? Or another thing you can do is expand the car park and make it bigger, and it costs him 50,000. The profit estimated at 2B, except that the probabilities are 60% and 40%, okay, respectively. So if he gets this done, this is his profit. All right. So how do we draw? All right. I will show you. What was the decision point? There were 3 options, correct? No change, raise the prices by 50%, or make the car park and make it bigger, right? Okay, so this is his decision, okay? Whether no change to his car park, or he makes a change. However, if he stays with option 1, what does it say in option 1? He will make a profit of how much? 100,000. So that is his outcome, correct? Now, if he has option 2, what is option 2? Okay. Raise prices by 50%. Okay, and there is a 75% chance. What is the 75% chance? That there is a competitor, correct? Okay, so which means 25% no competitor, right? Okay, so 25% no competitor. However, the outcome will be different. You remember? Okay, it says the profit with the competitor. You remember that? And the possibility. Now look, what are these circles again? Not your head. The circles is an outcome, correct? An outcome will have the calculation of an EV, right? Okay. All right. Now, which means now, what happens here? No competitor. You remember 2B? Yes? Or, option 3, you will expand, correct? Why is there 50,000 negative there? Cost. He has to expand, he needs to pay. It's a minus, right? Okay. Now, what happened here? If it was option 3, he says, it's the same like here, like 2B, right? Okay. If I have this, my question in the exam to you is, what decision he has to make? Can you calculate? So how do you calculate? Where do you start? From now you draw the 3 from left to right. Left to right, correct? Now solve it. How do you solve it? From right to left. Right to left. It's called rollback analysis. To solve this, it's called rollback answer first and put on the circles. Put on the circles, right? And then once you have the circles, then you put on the circle again. You understand? Means you make 75% of what is C, 25% of what is D. Can you do that? Answer me. Tell me, what should this car park owner do? Okay? So, what did you write in C? 30% plus, correct? Yes? What happened? What is the EB? Letter C. Or let's start with D. Or let's start with E. Easy. So E is what? What's your EB here? E. The E is easier. Yeah? 60% is what? 120,000, correct? So E is what? Yes, no? Sorry? Don't want to calculate. So?
170,000.
Sorry, say it again.
100.
You have to add it. Yes. When you get the EV of each one, you add it together. Total EV. Yes? Okay, what is your total EV? 180. Okay. All right. Next one, letter C, letter D. 185. Okay. C.
129.
Okay, is that correct? Now, what do you do next? How do I get B? How do I get B? Probability multiplied by what? C. You understand? Here, probability multiplied by 185. So what is B? 143. Yes? So what are you comparing now? I'm comparing this, correct? This. And then what happens here? What will I compare here? Minus 50. Don't forget the 50. So I'm comparing this. So what is his choice? See which one? With the highest, right? Which is option 2. Option 2. That is his choice. Yes? How nice, how easy, isn't it? Okay, try again. This multiplied by this. Plus this multiplied by that. It's similar. Right? Similar to this. But the outcome here, you cannot calculate it unless you calculate this. To go here. Yes. That's why it's from right to left. You cannot just calculate anywhere. From right to left. Fill it up first. Then you go to the front. To the left. Any questions? When I send you the Google Class, the PDF, I will also attach the calculation at the back. It's easy. All you need to do is the EB. Alright? Ready? I need to give you an example to practice. Ready? Okay? Alright, oh yeah, question. Oh, sorry. Okay. Huh? What? Because you spent 15. Option 3, you have to pay for the renovation, the expansion. With your net. Yes, you have to choose. Any other question, ladies and gentlemen? Okay, we're done. It's easy, this one, yes? Okay? Alright, now. Alright. Okay, here. I have a question for you. I need you to draw. I need you to draw a decision tree. Okay, ladies and gentlemen, are you with me? I need you to construct a tree for Captain Company. Alright, and then you do a recommendation. So first you construct, then you do a rollback analysis to give the answer to the question. Alright, let's see if we understand the question. Can you read the question quickly and tell me what is it that they want to do? Okay, so nice. They put it so nicely done. Shut down the sites. Major refurbishment. Refurbishment is renovation. Or not a major refurbishment, but a cheaper one. Okay. Good. If they sell, they make 5 million. Okay. So, it says on the second line, if they make refurbishments, so they took the two options is major refurbishment and cheaper refurbishment. If any of these refurbishments, every time, 2/3 of them is good results and 1/3 is poor results. Okay? And then the good result and the poor results are these in a major and a cheaper refurbishment. What do you start with? You start with a box. Correct? Yes? Right? Is there a probability here? Where's the probability? 2/3 and 1/3. So which means whenever you have a probability, do you have a circle or a square? Circle, an outcome. Yes? Okay, do it. I give you 5 minutes to do. If you get this right, you go for a break. Time for a break? Yeah, time for a break. Okay, give you 10 minutes. Because you have to build the tree and answer it. So build it first. Then we will see if your building is correct. There's cost. Cost of refurbishment is 4 million and 2 million. Now, how do you show the cost?
Measure from
in parentheses, cost is a negative.
Yes.
Yes, don't forget.
Okay.
So if it's a major refurbishment, the cost is 2 million and there are two outcomes. Good result and poor result. How many percent is this? 2/3 and 1/3. How about this? 2/3, 1/3. Correct? It says 2/3 is good result, 1/3 is poor result. Ready?
B.
None?
Major.
Let's take a look. Okay, very good. So what is your choice? Option 2. Okay, option B, major. Major refurbishment. Okay. Major. How much are you making if he does a major refurbishment, this campaign company? How much does he make? 7 million? 190? Are you sure? Double check. Okay, so, alright, let me see, what is the time? Okay, are we done? Everybody done? Yeah, okay, let's take a look at your tree. Is that the tree? Okay, not exactly like the shape, but yes? Is it the same like what you have? Yes or no? Correct? Okay, so the B is your expensive refurbishment, major, you can write major, or you have your lesser major, okay? So that's the outcome, 1/3, 2/3, 1/3, 2/3. Yes? Okay? And when you work back, what is the work back? Sorry, we're not moving first. Hey. I did it. Yeah, because there's a 666. As long as you understand that. Understood. Okay, so answer would be, the best would be the second one, 7,167,000. Yeah? Okay. All right. Okay, so That earns you your break, isn't it? Yes? Alright, so before that, before this actually is your EV where? Your EV on B and C. Yeah? Your EV on B and C is 2/3 of an outcome plus 1/3 of an outcome. Yes? Alright, again, I will post this in the Google Classroom. Okay? In our one. Alright? So, you can take your break. When we come back, sorry, we have to talk about value of perfect information. I'll tell you all about that when we come back. Okay? Position is option 2. Let me say that before I make a mistake.
program dev,
Rồi đến học thì project tập thì nói project tập rồi em cả cái tình lý tập thì rồi chính là tất cả học thì
chắc để lấy bằng tiền
thì lý đi mới đi viên cái tập
việc việc tiền
cái phim này
việc tiền
thì người ta phải đọc mấy cái gì cái việc này
suy chiខ្លួនឯងបានទៅមើលហើយគេមកវិញហើយគេដើរសាយនេះបានចេញអត់ណាហើយដល់ទូរស័ព្ទចេញចាប់ពីចាប់អត់មកដែរហើយចាំតែសុំវិញគាត់មកធ្វើញ៉ាំឯកសារគេឆ្លងធ្វើថ្មីទៅទៅមើលសិន
simulation simulation
no anh chưa ta nghe đây là vô lại đây là nó nghe cái con của bạn bằng ui nó không phải sai phải tổng lại gọi lố sao nè tôi nó phải nó phải tôi phải làm một mình đại tục khoan đâu đâu tục lên làm mà khi làm ba ba bạn nhảy đẹp mà riêng đi có một riêng được không khởi là nhảy không hay là có cái này này nó sẽ cho được khởi một lần lại anh muốn chúng thầy là bị sẽ cái là cái kia để tôi là bị quan của bạn là của bạn hay và để tôi của nhân của bạn là của đấy tôi chỉ muốn cái cả điều này hay bạn một của bạn sẽ có sẽ mình về để bạn hãy đi của bạn để mình làm mày hỏi sợ anh nói là không serious đó từ lòng cần
Nah, gọi thì ý rồi trong tháng đi tôi chặt xong rồi chặt xong cắt cắt một phần lý tất cả là tôi việc cắt cắt phần lý tới cắt khi số tới khoảng số cắt không chỉ đâu chụp mình sẽ biết là phải hai đêm tin con không ai không cho người hai con với họ ai không cho người ta đi xin cho mình sẽ u trong quá chia nó là con là con cho biết con trong biết tay con làm không ăn chỉ tức là ăn hạt rất là ăn là về chỉ có dùng mình á cho đây là cái từ đấy là ăn ăn cho nó mưa lớn ăn mà làm khi ăn đi còn ở đâu ta ra cùng ăn xong sẽ hai bậc mình sao cái gì mình sẽ đi sang trong hai người hàng rồi đây là sao thì ai ảo sao thì mọi người cho được hơn
xài experiment chứ như là xài cái đồ cho người dân học jadi trong khi các thì trong khai thác mình thì mình học trong hoặc là person system generate học right giống như là cái ví dụ do khi chúng ta khi
Okay, listen guys, let's continue before you leave because of the day. From meeting? It's too low. Tell us. Okay, we need to get you home otherwise. Alright, ladies and gentlemen. Right? If you make decisions and we said there's uncertainty, correct? And that is why there are probabilities, right? Okay. But you see, if we had the perfect information, if we had information, then how do we get this information? You do a market research, correct? Okay. But you see, if you have the market research, then you can get what we call a perfect information. Then you can make the decision without having to choose the probabilities and all, correct? However, the question is, how much are you willing to pay? Because market research and getting that perfect information costs money. Do you understand? Okay, costs money. Question is, how much are you willing to pay? And this is what the value of perfect information is. VOPI. Value of perfect information. How do we get that? Okay? The value of perfect information is given in our calculation here. What does it say? It says you get the EV with perfect, if you had perfect information, and you compare it with the EV without perfect information. No, the without perfect information is what we calculated earlier. You remember earlier? If you have 70% of that, 30% of the amount, correct? And you add it up. So you don't have perfect information. You just get the probability of what could be is the average outcome. You understand? That is the EV without perfect information. But with perfect information, you go straight to what is the probable outcome. So you can choose between the two outcomes. Okay? Now, I will show you what I mean. Sorry, VOPI is the difference between these two amounts here. Okay? That is the VOPI. Now, let's see. I'll give you an example. Okay? Alright? Now, VOPI. First, you get the value of the perfect information by getting the EVs of all options. Okay? Alright. And see which is the best. And you choose that. If you have perfect information, then you would choose the one that will give you the highest of all outcomes. Okay? Then you calculate the EV. The value of perfect information is the value that we said you will be wanting to pay for that perfect information. Example. Okay? Alright. Your choices are option A and option B. Alright. The profits are here. The profits will be strong in a strong demand, and the profit if the demand is weak. Now, strong demand happens 30% of the time. Weak demand happens 70% of the time. Okay? Now, the EV of A, okay, the EV of A would be what? If we don't have perfect information, what do we do? Like how we did earlier. Okay? What do you have in option? You have 4,000 at 30% plus 70% of the 1,000 loss, correct? Then this is your total EV, right? And then the same thing will happen for option B. You get the EV and then you add up. So, what is your choice? You choose B, correct? Understood? You choose B. B is this result, and these are the probability of the demand. Yes? What is this? This is your EV without perfect information. Do you understand? Without. Because you cannot choose. You cannot choose because you just need to get the probability. You get the weighted average, in other words. Correct? Okay. Alright. Now, what about if it was perfect information? Okay? What if there was perfect information that the demand is strong? What is your choice? If the demand is strong, what is your choice? A or B? If the demand is strong, what is your choice? A or B? A. If you have perfect information that the demand is weak, what is your choice? B, correct? Okay. So what you're going to do is, if you have perfect information, the first, if it's strong, you get the A, correct? If it's not strong, it's weak, you get the, what does it say? You get the B, correct? Okay, so again, let me write it here. This one is, with perfect information, you will choose, what option is this? Option A. This one you will choose option B. What is this? This is the strong demand, and the other one was the weak demand. And this is your EV with perfect information. Okay? Now, what was the original earlier? How much was the EV earlier? Okay? 870, correct? So 870 and 1620, okay, 1620 minus 870, 750 is your BOPI. In other words, if you're asked to do, you're going to ask a market company, a research company to do the work, you should not pay more than $750. Do you understand? For that perfect information. You? Okay, so let's practice. I think I have some practice here. Okay, understood? So again, how do we calculate VOPI? The EV with perfect information and EV without perfect information. Okay, let's practice. Okay, So,
Good.
John has asked a market company, market research, okay, which gives a guaranteed results of survey, which is 100% correct. Wow. Okay, 100% correct. All right, let's believe them. These results will enable John to ascertain the demand from his regular customers every month in advance of accepting a special order. What is the maximum amount that John should pay the survey? All right. So what does he say? These are the demands, and these are the probabilities of the demand. So the special contracts can be 900, 700, and 500. Okay. So what is this? This is a contribution table. So what are these amount here? These are already contribution. It's not profit. Contribution and profit different, huh? So the profit is net off, but it's also kind of return. That's that? Okay. So you have that. Now, if we don't have perfect information, what should you do? I don't have perfect information. How do I get the EV? And what is my choice? This is the demand, this is the probability, these are the results. Now remember, what are my choices? What are my choices? He has to ascertain what? To ascertain the demand from his regular customers every month. Okay? So, in advance. So he wants to know, does he do 300? Okay? Alright, so how do I get the EV? What should I do? Times the what? Probability times the... Okay. So for each one. So remember, maximum he wants in advance of accepting a special order. Okay. So what is the EV of what? So what is the EV of... Because remember, this one is total, correct? Total is 100%, correct? So what is the EV of 900, 700, and 500? Do you understand? Okay. What is the EV of each one of them? So what do I do? Just remember, the possibility of this happening is 100%, correct? Okay. So I need to know what is the EV of 900, 700, and 500. And what is your choice? Okay. What is your choice? Can you calculate? Give me quickly. What is the EV of each special contract? But remember, he has to choose the special contract of 900, special contract of 700, or special contract of 500. You have a table in the other slide, correct? So you need to find in the next slide what is your EV in this box here. Yes, correct. You do that. Here. So what is your EV here? Calculate what is the EV if you had the 900, which means if you had the 900,
What is the choice?
this is the one they want to accept. This is his regular customer. So which means if the demand is here, he can accept. If he accepts this special order, this is his profit, total profit. You understand? This is his regular customer. This one is a special contract. He wants to choose. Does he accept a special contract of 900, 700, or 500? So if his regular customers is only 300, he's deciding, will I accept 900 special contract, 700, or 500? And this is the profits every time he does that. Because remember, he has a regular customer and a special customer. So if he accepts too much of the special, he will lose the contribution on the regular customer. Okay? Contribution. It's a contribution table. So all these here are contribution. Yes? Yes, all these number here are all contribution. Yes, you understand? Okay. So all these here are contribution. This is the probability this will happen. So this one is his regular orders. So if his regular orders is 300 and he accepts 900 special contract, he will make a contribution of 4,200 and so on and so forth. Okay? Yes. Sorry? Here, the regular demand is 300 and he accepts this contract, he's making a contribution of 3,000. Yes. Yes, that he wants to choose either 900, 700 or 500. Maybe this is his contribution. No. It's his regular demand, and if he accepts this special demand, total contribution of both to be. Yeah, no. If he has a regular demand of 300, he accepts this special contract, this is his contribution. Understand? Contribution of both. It doesn't break down from which, but if he has his regular demand and he gets a special contract of 900, that is his contribution. Okay, and his total business between regular and the special contract. Something like that, yes. Okay, but your choice is equal. You don't have to add it up. Okay. Okay, are you done? Not yet. Wait, hold on. I'm still working. So which choice? If those who are done calculating, does he choose a 900 contract, a 700, or a 500 contract? Okay, yeah? Alright, so, let me see if you're worked already on it. Yes, correct. That's how we do it, yes. And you choose. You choose which one. Alright, so here is this result. Did you get the same one? And the result is, without perfect information, he decides on what? 700. The contract of 700. Okay, 700. Now, go back to the table. What if you had perfect information? What is the best result? Okay. What if you had the perfect information? What is the best result? So in other words, what if you have the perfect information that 300 is the regular order? Okay, 500 is the regular order. What is the best result? Okay. You want me to go back here? Okay. Alright, so let's say if the result, you had perfect information that 300 is the demand, regular demand, what is the best result? Which one is the best result? Look this way, look from left to your right. Which one is the best result? 4,000, everybody's listening? Yes. 4,300, correct? So I will take that, and that is the one I multiply. Earlier, we multiplied everything, correct?
Yes.
Yeah, okay. 500. What is the best result? 4,600. Good. 700 is your regular order. What is the best result?
5,000.
5,000. So whatever you choose, you multiply it with your probability and add the EV. Can you do that?
What is that called?
What is that called?
Very choose.
What is this called? This is called when you have the perfect information. What is the EV? Earlier, when you had to calculate all of the amounts, is without perfect information. Without earlier. perfect information. Because with perfect information, then you will choose the highest one already. Earlier, you had to apply the probability on all of them, isn't it? Yes? Okay, again, earlier, without perfect information, you had to apply the probability on all. Yes? Multiply on all, and then you have to total and get the highest choice. But here, you have perfect information, which means when you have perfect information that it is 300, then you choose the 900. If there's perfect information of 500, then you choose the contract of 700, because that one will give you the highest. And 700, then you choose. Yeah. Okay? So what is the EV with perfect information, and how much is John going to pay for the survey? Maximum he can pay. Huh? You check your totals. You're correct. You have to check your calculation. How much? Yes, but that is the EV with perfect. To get the VOPI, you have to get the what? You have to minus from? Yes, the two EVs. EV with perfect information, which is this, and EV of without perfect information, which is the earlier one. You understand? Okay. Alright, so what is our EV here? Anybody? Wait. Let's everybody get in line. Ready? How much is this? How much is the EV here?
2,000.
2,000? Okay, 2,000. Sorry, where am I? Without. And then this is? Why 2,007? We have to total it up.
What total?
Yes, of course. Not only 27. You don't only choose the 700. The first one is finished calculation. This one you have to get 100%. So you have to total it up. Sorry. Yes? Your choices and the probability. So now you have what? This is your total EV with perfect information. But not yet the answer. What is your VOPI? VOPI is this EV. What is 44? Minus 44. What is 44? The EV without perfect information. That was your first calculation. Yes? Okay. Question. Yes.
So the EV with perfect information. So what's the contracts that we are going to choose? Because here we sum up together 300, 500.
So here we are actually trying. Here he's saying if you have perfect information that 300 is going to happen, then you actually choose the 900 contract. What you're trying to calculate here is not to make the decision. Your decision here is how much you're going to pay for that perfect information. You understand? Okay.
Just the calculation, the
To
cost.
cost, how much you need to pay for the perfect information. Okay? You understand? So this is the maximum amount we can pay for the survey. You got that, everybody? Okay? A lot of multiple choice questions in your revision kit has an example of this. And most often, one of the questions in your 35, how many questions do you have in the multiple choice? 15 questions, correct, thank you. 15 questions. Out of the 15 questions, Sometimes, most of the time, this one will come out. How to calculate EV, because it's a small question to put. It's a small question. You understand? It's a small information they can put, so you need to be able to calculate value of perfect information. Okay? All right? Okay. Next technique. Oh my God, we have so many techniques. Do you remember all of them? What is the decision technique in this chapter? There's so many. From the beginning, we have CVP, correct? Analysis. Then we have linear programming. You remember? What else? Another decision technique that we learned. So linear programming, CVP analysis, pricing. You remember pricing? Yeah, especially MR is equal to MC. Yeah, the technique, eh? Alright. And then you have what? You have pricing, marketing strategies. Ooh. And then you have what? You have relevant cost, relevant revenue. Remember that? Short-term decision making. And then here, in this chapter, we have learned a lot. Expected values, correct? What else? Maximin, maximax, and minimax regress, correct? Decision tree. Alright. Then we learn how to calculate value of perfect information. Because then I can decide whether I go with the survey or don't go with the survey. Because if the survey is too expensive, then I will settle with EV without perfect information. Let's say the survey said, no, I charge you $500 for the survey. Do you think Mr. John should go ahead? Yes or no? Should the market research company said, I will charge you 500. No, because the maximum you can pay is 200. Otherwise, even if you make the correct decision, you will lose 300. You understand? This is what it means. You get it? Your expenses will be over than the profits. You got that? Okay. Now, what about here? Another technique is called sensitivity analysis. When companies decide on something, they will have to say, okay, if there is a change between the actual and the standard, okay, which one with a little bit of change will wipe out my profit? So that means it is sensitive to that kind of variable. You understand? Okay? That is what we call by sensitivity analysis. You assess if there is a change in the variable expense, because that's what changes, the variable expense, like material costs, labor rates, you understand? Selling price can be variable, it should be discounts, correct? Okay? You probably will think, when you go to a store and then you ask them, oh, give me 5% discount, they say, no, we cannot. How do they know they cannot give 5%? Because they make a sensitivity analysis. Because if they give 5% discounts, the whole profit will be gone. That's what they tell you, right? Oh, I cannot give you 5%, we cannot make profit anymore. They know because they do sensitivity analysis. How does it work? Okay? You actually identify what are the different variables and what is the effect if there is a change in that variable to your profit. Okay? The lower percentage is more sensitive. Okay? In other words, if only 2% change in the material cost, the profit will go out. 2% change in the selling price, the profit will disappear. Which means if it's 2%, then I cannot give 2% discount. You understand? It will wipe out the profit. So what companies do is they will analyze, okay, and say, okay, what are the different variables that will change, that there could be a decision to change, and what is the effect on the profit? So you make the decision and see how many percent change will affect the profit. Okay, I'll give you an example. Okay. Oh, for example, here. All right. Okay, so what happens here? This is company A, P, is considering, okay, I will use the wrong side. Again, wrong slide is wrongly. Okay, go ahead. The question is first before the answer. The answer is first before the question. Okay, here's what happened. Alright, access. So what happened here? There's a new product. The sales is 100. The cost is what? Sorry, 20 and 30. So the cost is 50, correct? Okay. Overhead is 30. And you have a profit of 20. You understand now? Sorry, the lines are everywhere in the place. My slide wants to go over, isn't it? Okay, here we go. Now, it says, what about if there's a change in cost or unit sold? Which one is more sensitive? So if there's a, let me see, if material costs were to double, okay, what happens? If material cost is to double, look, it becomes what? 40. What will happen to the profit? The cost will increase by 20. So this one will be what? Profit will be 0. No profit. You understand? Correct? So which means if there's 100% change in material cost, it will actually have a loss. Now, if sales would fall by 4,000, that is 40%, okay, what will happen? If this one becomes 6,000 only, how much will be here? 60, correct? Okay, so 60 minus all these, what will happen to the profit?
No.
Okay, so 60 minus 50 minus 80 is negative, lost 20,000, correct? Okay, so therefore, what happened? Okay, what is more sensitive, therefore? Okay? Something is missing in my slide. Okay, so option 1, sorry, what is option 1? Option 1 is material cost. Sorry, something is missing. Is yours correct? No. So sorry, everybody. Hold on. Huh? Sorry, guys. Hold on. I need to do it manually. Hold on. Sorry, guys. 1 second. Bear with me. What happened? Hold on. Alright, Alright, so let's see. Let's do our own analysis. Forget about this. Okay? Here. Don't worry, guys. Okay, here we go. Alright, let's do our own sensitivity analysis. Alright, so. Alright, first, let us look at sales, okay? Alright, so if, alright, so option A is sales would be what? If sales changes from 10,000 units to, it goes down to 8,000 units. Okay, how many percent decrease is that? Decrease of how many percent? Huh? 20%. Okay. So 20% decrease, what happens to the profit? Can you tell me? Okay, what would happen to the profit? Give me quick.
Zero.
So if this decreases by 20%, profit will be? Zero. Very good. Okay, letter B. So the first one was sales, correct? Now, next one. Let's say material costs will increase by 100%. What will happen? Materials. It will be now from $2, it becomes $4. So how many percent increase is that? 100% increase, correct?
Yeah.
What will happen to the profit? Zero. Okay. Now, what happens to the labor? If labor will increase from $3 to $5, what will happen to the profit? How many percent is that? 2 over 3 is increase of 67%. Profit will be 0. What about fixed cost? Okay, let's say fixed cost, fixed overhead will increase by 2/3. Okay, from 30,000, it will become what? 50,000. How many percent is that? 67%, correct? Is that correct? Profit will be 0. Okay? Now, tell me. Okay. How about selling price? If selling price will be from $10, it will become $8. How many percent again? 20%. Profit will be 0. Okay? So if you look at that, in which variable are they most sensible to? Sales volume and what?
Selling price.
And selling price. Yes? Which means they should not give any discounts higher than 20%. Yes? Or their sales quantity should not go lower than 8,000. You understand? That is their sensitive. They're not very sensible to, and they're not very sensitive to changes in prices of overhead and of materials and labor. Correct? Okay. So, which means, if what happens here? If it says if the materials will cost more than $4, they should find another supplier already. Do you understand? Because they cannot buy at $4. Do you understand? So how does that affect decision making here. Because if you're the purchasing manager, you have to decide, do I accept this offer of $4.50 or not? In this case, no, because your maximum is $4. Otherwise, you could start making losses, correct? At $4 increase, you're breaking even. Zero profit means break even. You understand? So, in sensitivity analysis, you actually find out at which variable, in which area are they actually sensitive to any slight change, it will affect the profit. Yeah. That's what sensitivity analysis is. Okay. All right, clear? So that is what happens there. Forget about my other slides. Doesn't make sense. Okay. Simulation models. Last technique. Sorry. Last technique for the evening, hopefully. This last one, there's more. Yes, that's the last one. Okay, good. Okay, last technique. What happened in simulation? Simulation means you actually you kind of duplicate what could happen. Example of a simulation. For example, if you train pilots of airplane, what do? They don't get them to practice on an actual plane. You understand? Okay. They put them in a kind of like similar to the airplane cockpit, but they put computers, but it's not flying. You understand? Or before they send astronauts to the space, they have to simulate what it feels like inside the rocket, what it feels like when they land in the moon, correct? But they're still here, except that they are in a situation. So when you do simulation in accounting here, we actually devise a model as if you are in the future. You understand? As if you are in the future. So when you are thinking that you're in the future, then you can actually make the correct decision. So how do you do that? When you look at the probabilities of what will happen in the future. Okay? And then you make your choice. So what happens here is that you have several variables and you give random numbers. How do you give the random numbers? It's based on probability. I will show you. It's very easy and very funny. Alright? Here. Okay, here's what happens. Example. If I am someone who wants to decide, okay, on day 1, day 2, day 3, and I am a bakery, yeah, I'm selling nompang, and I have to know, I don't make the bread when you order, isn't it? I make the bread in the morning, and you come and you buy nompang, correct? Yes. The question is, in Monday, how many nompang should I do? On Tuesday, how many? On Wednesday, how many? So, here's what happens. Alright? Daily demand can either be 17, 18, 19. And there's the probability of this happening. So remember, the probability always total to 100, correct? Now, I assign numbers. How many numbers do you think I will assign to 17 if my probability is 15%? How many numbers is that? From 0, 0 to 14, how many numbers? 15, because the probability is 15 out of 100. Do you understand? Okay? Alright, next one, 18. How many numbers should I assign? 45. 45 numbers. Do you understand? Okay. Be patient. You say, what are you doing? It's crazy. Wait, it's coming. Okay? So now you assign number, right? Okay. Now, okay? I go to my computer and I ask the computer to give me 3 random numbers. So the computer gave me 76, 13, 01. It's not the birthday of anybody, but the number gave me a random number. You understand? Okay. Or if you don't want the computer to give you, you put all this, you write the numbers in a piece of paper, small piece of paper like this, 00, 01. Yeah, small, like a ruffle number, right? Okay? And then you mix them up, right? And then you pick 3 numbers. You got that? Yeah? It's random, this is. Now, what happens here? If you pick 3 numbers, 76, 13, and 01, so day 1 is number 76. So where is number 76? you prepare 19 numpang. You got that? Okay? Alright, next number, 13. Where is the number 13? 17 is your number of numpang to prepare for day 2. You understand? Okay, this is why I told you it's funny, isn't it? Okay? And then, number 101, of course, is 17. So now, I can make projection 19, 17, 17. This is what I'm going to do in my business. You got that? Okay? Simulation. Monte Carlo, actually it's called. Monte Cristo, Monte Carlo, something like that. Okay? Alright. Okay, give me. Now, look at this, huh? I'm asking, you are the owner of the shop called Test Me Chocolates. Nice, isn't it? Test me. Okay. Test Me Chocolates. And they make chocolates. Alright. Historically, their demand can be 0. There is 0. Sometimes they can sell 10, sometimes they can sell 20, etc. Now, those are the probabilities. Yes? Alright, so if those are the probabilities, how will you make the projection for the next 10 days? What is the first step? You have to do what? You have to assign what? You have to assign numbers, correct? So you go to the next slide. Okay, the next slide. So what does it say? 0, 10, 20, correct? Yes? Then, so what are the numbers you're going to assign? So you have, right? So you have 0, 10, 20, and the probability, right? So can you write the numbers on the side? What is the number you're going to assign? And tell me if these are the numbers. Okay, and these are the numbers. Second box. These are the numbers for 10 days. How many chocolates will they make for each day? Can you do that? Okay. So what numbers will you assign for the first line? So it's going to be 0, 0, 2. How many numbers are you going to assign? 0, 2. Yes. Sorry. 2 numbers only. So 0, 0 and 0, 1. 0, 1. Not 0, 2. 2 numbers only. Okay, you got that? Okay, assign quickly. No, you have to assign here. 2 numbers. 0, 0 and 0, 1. Because there's 2% probability. Yes, and then from 0 to 3. So let me show you the previous one. Okay, since you have this. Alright, so how did I assign? You remember 0, 0 to 14 is 15 numbers, correct? Yes? So the demand of 0 is how many probability? 0.0. What is the probability of the 0 demand? 0.02. So how many numbers would you give? 0, 0 and 0, 1. The next number is what? 002 to, sorry, not 002, 02 and up to
19.
So 02. How many? 18, right? You need to. So 02, 03, 04, 05, 06, 07, 08, 09, 10. Okay? 11, 12, 13, 14, 15, 16, 17, 18, 19. You understand? Okay, you got that? 19. Is that correct or 18? Am I correct or no? Let me see. I put 18, huh? 18, not 19, right? 18, okay. Okay, again. 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Correct. Is that correct? Unless my fingers are wrong. Okay, so let's see. Okay, so 19. Yes? 18 pieces. You need 80 numbers, right? Yes? Okay, you got that? Okay, so on and so forth. You now know. Once you know the second one, you know the rest. Yes? So what is the box here? The box here, it says, how many days he wants forecast? How many days? 10 days, right? So day 1 up to day 10. How many chocolates should they prepare? So this is the random number. 23 is day 1. So what is the demand of 23? Where will you find 23? Which demand? 20. So that is the number of chocolates they will prepare on day 1. You understand? So again, if you have the probability will dictate your numbers assigned. Correct? So this one means 2 numbers. This one means 18 numbers. This one means 13 numbers. Do you understand? Now, this is a random number generated by a computer. So once you have the number, you have to find 23. Where do you find 23? You find it here. So therefore, first day is how many? If 23 is in there, the demand of the first day is 20. You get that? If the demand for the random number for number 2 is 48, where is 48? 48 is here. So which means your demand for day 2 is 20. Sorry, say that again. Oh, no, it's not 30, sorry. What is the previous one? Sorry, 3%. Sorry, this one. Thank you for showing me that. So this one should not be 30, it should be 0.03. Sorry. Yeah, its previous one is 0.03, sorry. Should be 0.03. Thanks.
How do you get the range of the number of time on the first step of the test?
Sorry?
The range between 0, 0, 1.
Here, based on your probability.
How much?
The probability is given, right?
No,
How?
number of times.
And here, I'm assigning any from 00 to 01. There are 2 numbers. 0001, 2 numbers. You understand? Or 01, 2, 3. Starts from 0. So from 0 to 1, then 2 to. Yeah, you understand? Numbers, just number. You got that? Everybody understand? Okay, so I told you it's funny, isn't it? Okay, you got that? So this is simulation technique. Any more questions? Oh, you're okay? Still okay? Okay? Alrighty. Okay. Clear? Okay, everybody's clear, right? Okay, alright. So let us learned. Yes? Okay. What is this formula here? Do you remember? What's this? The sum of probability times outcome. This is where you use what method? Expected value method, yes? Yeah? So when we use expected values, we get the total of the EV. Okay? Total EV. Now, again, another formula. Value of perfect information. Do you remember that? Okay? Value of perfect information. So you get the EV with perfect information minus the EV without perfect information. Okay? Alright, so let's summarize. Remember, when we talk about risk and uncertainty, which one of these is something that you can know the outcome and the probabilities? Is it risk or uncertainty? Again, out of risk and uncertainty, which is the one that you actually can find out the probable outcome and its probability? The risk or uncertainty? The risk. Okay? Uncertainty is not something that you cannot make a statistical probability. You cannot. There is no way that you can actually find out what could possibly happen. Okay? Expected values is when you actually sum up the outcomes and its probability. Okay? So you actually use expected values when you are addressing risks. Right? Example is minimax, maxima. Do you remember the risk seekers and all that? Did we use expected values there? Answer is yes. Okay, we use expected values. Alright, risk-based decision. I think we had it very well. You need to be able to learn how to do payoff tables. And what is that? Another table. Opportunity loss table. Okay? Now, we also looked at joint probabilities. You remember both the outcome, the situation and the choices have probabilities. What did we do? You forget? Again, in joint probabilities, both the choices and the situation had probabilities. So before we get to expected values, there's some step that we need to do. What is that? Find out the what? The new probability, correct? Right. You forget? Oh, no. Okay, wait a minute. Let me go back one sec. Joint probability, very important. This is something new. Okay? Right. They probably will check on you on this. Okay, go back 1 sec. You remember this? If you have a joint probability, what will happen? Here. Okay, you have, this is the variable cost and this is the probability this variable cost will happen. And this is the variable, the fixed cost and this is the probability this will happen. Correct? So, the combination will affect your profit. So you have to prepare a two-way data. Okay? So what will happen here? Okay? So if you have, these are your variable costs and these are your fixed costs. What are these here? This is your 290,000 is your profit. Yes? So if you have a combination that your variable cost is 12 and your 100,000 is your fixed cost, this is your profit. You understand? Okay. So it's that combination. If this is the combination, this is your profit, yes? But it's constant. The selling price is constant. The unit is constant. Okay? So what do? You have to prepare a joint probability table. How did I get 0.08 again? You have to multiply 0.4 and 0.2. Do you understand? Okay, so remember, these were the variable costs, this probability is given, right? These are the fixed costs, and these are the probability. What do? You have to calculate this. Joint probability table. Now, how do I solve the problem? How do I know what is the profit? You remember the profits here? Sorry, here. What will I do now? I will have to take 290,000. Okay, watch it. Watch. 290,000 multiplied by what percentage? 0.08. And that is that. You understand? Okay. So you continue. What is your total EV? Your expected value of profit is you add all that. 245,000. You understand? Joint probability is called. Joint probability table. I also sent you this one through the Google Classroom, yes, in a OneNote. Oh my goodness! I should call you each one of you at home. And I should, hello, this is Maria speaking. Did you open your Google Classroom today? Maybe I should do that. One day, you will hear me on the phone. And if you did not, then we will go watch a movie. Alright, anyway, joint probability table, you understand? Okay, and then of course, recalculate the outcome. Decision tree, the squares is what? Decision points. The branches represent choices. The circle represents outcome, which means you have to calculate an EV. Right? Okay? And then of course, you need value of, okay, the decision tree is where you use imperfect information because you have to calculate all of them, correct? Okay. Value of perfect information, okay, if you had perfect information, then you would make the correct prediction or correct decision. Okay, but what is the cost of getting that information is what you calculate here. Alright, sensitivity analysis is a way to see which variable your business is very sensitive to. So you can help in decision making. Simulation model gives you, again, a way to simulate the future using the probabilities. Okay, probabilities. Alright, where will I find this? You find some examples in the math exam in 2016. Okay? And they will ask you, for example, to calculate EV, right? Research information. I don't need to talk about that. Decision tree. Oh, look. Value of perfect information. Look how many times has come out. Okay? So you need to look at that as well. They probably will not ask you to draw because it's a CPE. But they will ask you, they will give you already a tree. And they will ask you questions in relation to the tree. Yes? Okay. So you need to be able to make the correct choice and correct answer. Alright? Since you know how to make a tree, it's easy for you to translate whatever they give. Alright? Okay, good. So these are the two things that can come out. Decision tree, value perfect information, EV. How is Maximax Maximin? They like this, okay? See, they give 6 marks. They will ask you to calculate a lot. Okay, this is in the long part. Long question. Okay, good. Alright, any questions here? Okay, what time is it? Oh, we have time. We don't have time, or we have time? Any question? What? Okay, let's make a question. Where is it again? I will go to you. Okay, sorry. What's that? First, before I go to your question, this is budgetary systems. Can you take a copy, please? Okay. So see, they got the random number. Yeah? So where is that? Where is it? Alright, next one. Next one is, okay, this one is additional information only. I found this in Kaplan, so I need to share it with you because you have BPP, correct? Okay. Everybody's laughing. No, I won't start. Otherwise, I will repeat it anyway tomorrow. Because between today and tomorrow, I'm sure you will forget something. Okay? Right? Any questions? More questions? So please bring those materials tomorrow. Where do we meet tomorrow? Yes, where? Where? Go back to the old one. Huh? We don't need the decision tree anymore. We go back. Unless you like it here. You like it here? You like it here, huh? Fortunately, we have to go back. Here is closer, isn't it? Yeah? It's more personal, correct? It's good. Try tomorrow at lunchtime to be here. The sun is like, not good at daytime. Nighttime is nice. Okay? Something new. Okay, good. So, again, I will post in your Google Classroom the OneNote. Alright? Read on the budgetary system and I'll see you on Monday. Okay? Thank you very much, everybody. We'll see you tomorrow. This is 4.2 times 1. So if you 6 multiplied by 1 plus 4.6 multiplied by 1 you Yes, the highest. Without perfect information, that's your choice. Yes. 50 numbers. Because this is the probability, correct? If this one is 23, this is the demand. I'm asking for demand. This is what you put here, not the number. Not the number. No, the number is only to guide you. If the number comes out, this one will guide you how many numbers you give. Okay? Now, once you get the number from the computer, that number, if it falls between that, then which means any number, this one, will appear. The demand on that day is 30. This is your demand. So how many is the demand? It's 48. Then this one here is to know how many numbers to assign. When you get the number randomly, you will tell, this number falls here. Then you go back and say, oh, that's 20 information. Clear now? Good job. Thank you for asking. Next question? No more? Super hungry. Which one? I need to know which one I'm going to put here. Bye. See ya. Oh, thank you very much. Oh, you don't need to do that. Go and have some rest. Eat a lot. Maybe you're not eating. See, the doctor said that, no? Oh, ganda.
Không lẽ nó là gì cũng nghiệm phải thay mà em qua rồi ăn không được đâu sao đây xong cái là nấu sữa to này kia có đồ ăn đi đến đấy thì mình sẽ nhưng mà ta thấy mình lúc của nó đi cái đất